I should have been recording from the very start, but I forgot. Okay, so 1, 2, 3, 4, 5, 6. Those two will give us approximately a seventh. Ooh, and then it gets kind of gross. So this one up here is about a full box. So we've got about a full box, another almost full box, and then about a half a box. So if we split that half box into the two pieces that would go to make those other two full boxes, that'll probably make those two completely full. So why don't we say between those last three pieces, so this piece, and this piece, let's say that's about an eighth and a ninth box. Wiley should have a large enough tolerance that it shouldn't matter if we're off by like half a box. So let's go ahead and say 9 boxes there. And so then we need to figure out how much area is below the t-axis, and then we'll go from there. Sorry, I'm trying to multitask and it's not working. There we go. So if we look at the area below the x-axis, we've got one full box here. And then we've got, two almost full boxes and then a little bit of a sliver. So if we kind of add all of these three together, it's probably going to get us another box and a half. So up to about 2.5 boxes, I would say. So we've got 9 boxes above the t-axis and 2.5 boxes below the x-axis, approximately. So, did I want to say 2.5? Yeah, 2.5 boxes. If you said 3, it would probably be fine, but I'm going to go ahead and say 2.5 boxes. So essentially we start from home, and this distance, does this have a name? It does, it's v of t. So if we go from 0 to 3, well, we have 9 boxes. And then remember, we have to consider the area of each box. So these are 1 by 20 boxes. So 1 times 20 for the area of each box. So that means that the area underneath that part of the t-axis is 9 times 20 is 180. This will be kilometers away from home. And then if we consider from 3 to 5, I'm just breaking it up because I want to. You don't really have to break it up, but I'm breaking it up to just separate the away from home from towards home pieces. And then these are still 1 by 20 boxes. So 2.5 times 20 give us 50 kilometers towards. And let me try to move this down really quick. So we've got all the pieces, and now we just have to figure out what the actual final answer is. So essentially we start at home. So we start at home. Oops. So we start at home. We travel 180 kilometers away, and then we turn around and we go 50 kilometers back. So essentially, how far away from our house at that point? It would be 180 minus 50, so 130 kilometers away. So that should hopefully be the answer to the first part. Let me triple check what Wiley wants. Yeah, they have 130 as well. So again, depending on the values you're given in your graph, it could be potentially different for you. But for the person who asked that question, I'm using yours. So. And then we're asked, when are you farthest away from home? Well, that's probably before you turn around and go back towards your house. So that would be at the end of those first 3 hours. And we've actually already calculated how far we've gone in those first 3 hours. So when are you farthest away from home would be when t equals 3 before you turn around and go back. And then how far are you at this point? Well, we found that the distance you traveled between 0 to 3 was 180 kilometers. So 180 for the third piece. Does that make sense? Hopefully. And then there was... Question 5, 5.5. So the next one someone wanted me to go over was question 5 and 5.5. Oh my good Lord Almighty. Wiley is really fighting me right now. It doesn't want to let me do what I want. Come on. So this one is kind of like one of the ones that we went over. Ooh, gosh, what? Not the last time, but I guess the time before that. So maybe, no, Wednesday was your exam. So Monday, last Monday was probably when we went over one like this. But sorry, just one more second and then it'll be up. All right, here we go. So this one, again, I'm pulling the exact question from the person who asked it. So we have the marginal cost is given in the figure below. If the fixed costs are $10,000, estimate some things. So the only one you haven't got yet, so I'll just go over the one that you haven't got yet, unless you want me to go over the other ones, Caitlin. But so the total cost to produce 30 units. So the fixed cost was $10,000. And we want to know the exact cost of 30 units. So since we're given the marginal cost here, remember that we can find the total cost by, so notice the difference between C prime and C. So since we want the actual cost of producing 30 units, this is where we'll take the integral from 0 to 30 of C prime. And then we have to add on the fixed cost. And the fixed cost is just, well, the fixed cost, another way to write that is C of 0. But the fixed cost is given to us as the 10,000. So essentially the thing we need to find here is the main thing we need to find is this integral here. So we're going to need to count the boxes between 0 and 30 for this function. So let's go ahead and do that. So if we count our boxes just up to 30, so we're going to stop here. We're not going to count all the boxes. So we've got 1, 2, 3, 4, and now we got to start piecing together. These two here will get us about a 5th box, and then the last piece, there's no real way to piece that together into a new box, but between this and the tiny little sliver, that'll get us about half a box. So it looks like we'll have a total about 5.5 boxes here. Let me zoom back out real quick. So if we want to take the integral from 0 to 30, we found it to be approximately 5.5 boxes. And again, we have to take into consideration the area of each box. So we have a 10 by 8 box. It's interesting. So we have a 10 by 8 to give us the area per box. So 5.5 times 10 times 8 will give us 440. Oh, of course, Wiley's being silly. Let me just triple check that it matches. Perfect. So your answer almost looks really close. It's almost like you were just missing something simple. Maybe an arithmetic error. I didn't mean that to sound bad. I just meant an arithmetic error. So we have 440 plus that 10,000 for our fixed. So we would get this approximately 10,440. Questions, concerns about that, or any other questions anyone would like me to go over before we jump to the thing I pulled together? All right. So especially now that whoops, I didn't mean to do that. Oh wait, no, we're okay. So especially since we just spent some time on that, which is fine. We won't get through too much of this stuff that I created, but I'll put up the full answers in case anyone wants to look at it later. This isn't anywhere on Blackboard, so I'm going to give you like 10 seconds to write down the question if you want to write it down before I go over it. But essentially, I've tried to create a question, multiple questions that have as many topics as I can pack into them as possible. So it's going to seem like a lot of material, and that's just because that's how I created the question. So again, write this down if you want to have it. Otherwise, I will post the answers to it later when I get the chance. So say we open a bank account with $5,000 and the account earns 2% interest annually. The first thing we want to do is write an equation for the amount you will have after T years. So this goes way back to chapter 1 material. So this is an exponential function. So remember, we have two forms of an exponential function. We have p naught a to the t and we have p naught e to the kt. And remember that the a is made up of 1 plus the rate, and then the rate in the kt form is just the k. Also remember that if you want to use, or if you're going to be asked to use the e to the kt form, they will use the word continuous. If you don't see the word continuous, you should probably just default to the a to the t form. There are some situations where you can choose, and that's essentially where it doesn't say the word rate or continuous. But I would just say if you don't see the word continuous, just default to e to the p naught a to the t. So here we want p naught a to the t because it says annually. It doesn't say anything about continuous. So the p naught is the initial value, so that's going to be the 5,000 that we start the account with. And then the 2%, so remember the rate comes from the percent, but we need to change the percent over to a decimal. So our rate here is 0.02, which makes the a value 1.02. Also remember that if you're, so in this case, it wouldn't make sense because it's interest. But say it was a different question where the rate was decaying, say it was a population that was getting smaller. Remember, if it's a decay rate, you have to make the rate value negative, which would make the a value less than 1. But here, so our equation would be 5,000, 1.02 to the t. And that's all we want for that part. And then for the next part of the question, how much will we have after 10 years? And then how long until you have $7,500? So let me split that up because that's two completely different questions. So the first thing we're asked is how much will you have after 10 years? That's essentially just a plug and jog. You just take your equation, you plug in 10 where you see a t. So we've got 5,000, 1.02 to the 10. And that's essentially plug that sucker into your calculator. That's exactly what I'm going to do because I don't know what that answer is. 1.02 to the 10th power is $6,094. And since it's money, let's round to 2 decimal places, so 97 cents. Now, a slightly more complex question is how long until you have $7,500, because that's not plugging in 7,500 for t, that's setting this equal to 7,500. Oops. Blanked there for a second. And now we want to essentially solve this. So since this has a t and the thing we want to actually solve for is that t value, this is when we have to use our natural log process. Now, let me even put natural log of x because natural log by itself without anything doesn't actually mean anything. If you write ln without anything attached to it, it technically doesn't mean anything. So remember, when we want to use these natural logs, we need to get the thing with the exponent by itself. So the first thing we would need to do is divide by this 5,000. So 7,500 divided by 5,000 is 1.5. And then once you get the thing that has the exponent in it by itself, that's when you take the natural log of both sides. And remember, you can technically use log base 1.02 if you really like and you know how to use that correctly. But let me, whoops, that should be inside the parentheses. And remember, the reason we do that is because we have this natural log rule that says if we have the natural log of something to a power, we can essentially bring that power outside. So I'm running out of space. I'm writing too big. We can bring that t out in front of the natural log. And then if we want to solve for t, we divide both sides. So I wrote it slightly, whoops. Can't talk in. Right at the same time. So of course the t kind of jumped over to the other side, but notation, so it doesn't matter. So natural log of 1.5 divided by natural log of 1.02 will give us that it'll take about 20.48 years before we get $7,500. Which almost makes sense because after 10 years we had gained $1,000, and it's gonna not be linear like that, so you don't get $1,000 every year. So since we got $1,000 in 10 years, it makes sense that about 20 years would get us $1,500 from what we started with. I'm going to scroll down to the next part to let anyone write it down if they want to, but I'll wait like 10 seconds before we go over that. Also, in case there's any questions about what we just did. So the next one asks us to write an equivalent equation for continuous interest. And then we're going to use that equation for the rest of the problem. So the reason I bolded equivalent here is because remember there's the two forms, but if you're just asked to find the equation with continuous interest, then you just let that 0.02 be the the k value. But here, this is when we want to find the equivalent continuous interest form. So remember, there's the two forms that I just wrote above, but now I've scrolled past it a little bit. So this was way back when we said, okay, if we want these two to be the exact same thing, what's the only difference between the two? And the only difference is the a versus the e to the k. So essentially, if we want an equivalent equation, the p naught's not going to change. We're still going to have p naught as 5,000. But essentially, if we want this a to the t to be equal to an e to the kt, excuse me, we essentially need to let a equal e to the k. Well, the a value we have is 1.02, so we want to let that be equal to some e to the k. So now we need to solve for the k value. Well, since that's in an exponent, this is again where we'll want to natural log both sides. I'm going to bring the k out at the same time. Hopefully it doesn't freak anybody out. And then remember that the natural log of e is 1. So that kind of doesn't really disappear, but we can kind of not quite consider it because anything times 1 is itself. So we have that k is equal to the natural log of 1.02, and the natural log of 1.02 is approximately, I'm going to take 4 decimal places, and that's going to be 0.0198. So that's the k value I'm going to take. So then the equation that I want, my p naught didn't change, e to the k t. So this is the equivalent continuous interest equation. If it didn't say the word continuous, we would have just put 0.02. And I know it's very close. It's very close because it's a very small interest rate. The larger your interest rate, the bigger the difference between those two are going to be when you do equivalent forms. So don't just assume that it's always going to be highly similar. Sometimes the difference can be larger if it's a larger interest. But anyway, so if you don't see the word equivalent and it just asks for the equation with continuous interest, then you just let the k value be t interest. Okay. So the next thing we're asked for is to find the rate at which the amount of your account is growing. As always, let me know if I'm going too fast. But find the rate at which the amount of is growing. So essentially we want the derivative. We want to know that rate at which this is increasing, so we want to find p prime. So I know we're pretty much just focusing on antiderivative rules, but now we've got to shift back to our regular old derivative rules. So the 5,000, remember that's going to come along for the ride. And then we have an e to the something. I'm going to treat that as a chain rule. I know we do have that e to the kt rule, but let's treat it as a chain rule because that's technically what it is. So the derivative of e to the something, remember you just keep it the same, e to the something. So you still get the e to the 0.019t, 0.0198t. But then we have to multiply by the derivative of that something, of that exponent. So we'll get 0.0198 at the back as well. If you treated that as an e to the kt rule, you would get the same thing. And then if you multiply those together, those actually come out nicely. It just turns into 99, which was not something I was expecting because I pulled this question off the top of my head. But there we go. So that's all that question was asking. We just wanted to find the rate. So technically the rate is an equation and it depends on what value we're looking at. And then I think this is the last piece of this question. So again, I packed oh wait, no, two different pieces. I've packed a lot of different topics into this question. So we started with kind of chapter 1 material and that question was chapter 2. And so the rest of it is kind of chapter 2 and chapter 3, I guess, material. Anyway, so now we want to find and interpret f of 5 and f prime of 5. And I should have been careful with my notation here. The f of t is just the original equation, so the 5,000. And we're using the e equation for the rest of this. And then the f prime is, of course, the derivative we just found. I probably should have called it p and p prime, but I wasn't thinking. Nope. That had reduced to 99, e to the 0.0198t. So of course, to find f of 5 and f prime of 5, we just plug in 5 to these equations. 0.198 times 5. And I need to figure out what that is. So f of 5 is approximately 5,520 and 33 cents, let's say. And then for the derivative value, plug in 5 for the derivative. So 99 times e to the 0.0198 times 5. And this is approximately 109.30. So if we want to interpret these two, the first one is, kind of just a normal value, if you will. So this is just 5 years, $55,000, $5,500. So essentially after 5 years, the account has this $5,520.33. And again, remember with these interpret ones, as long as you get the point across, I don't really care how it's phrased. You could say you have $5,520.33 in your account after 5 years. Anything that gets the point across that 5 years gives you the 5,500. And then for interpreting the derivative, remember we kind of have two choices. We have the rate way and the slope way. So since this is kind of for review purposes, I'm going to do both. So the rate way and the slope way. So remember for both of them, you always have to tell them where you start. So remember to always write down the x value for those. So we'd have to say something like after 5 years. Now, if you're going with the rate way, this is where you're then just going to tell them if it's increasing or decreasing by that derivative value. And since the derivative is positive, that'll be increasing. So I will say something like, so we need to make sure to bring in the context. The context here is an amount of money. So I'm going to say the account balance. So after 5 years, the account balance is increasing by 109.30, and the units here would be dollars per year. So remember, the units of a derivative are kind of the change in y over change in x. So the y values are dollars and the t values are years, or x values if you prefer. So dollars per year. You could write out the word dollar per year, of course. And then for the slope, remember we have to start off the same way after 5 years. But this is when we say we're essentially increasing by 1 year, which increases the account balance by $109. So I'm going to say something like, for each additional year, the balance increases by $109.3. Remember, in this case, it's just dollars because you take care of the per year with essentially saying for each additional year. And also remember, with the interpretations, it's one or the other. You don't have to do both. You do want to be somewhat familiar with both ways. Say this was a multiple choice question and I gave the answer as the slope way instead of the rate way. If you can't at least, recognize the slope way, then you might not be in a good spot. But in terms of just writing them, you would only have to pick one or the other. And so now this is the last piece of this question. Again, shoved a lot of different topics in this question. So hold on a couple seconds in case people are still writing stuff down. So here we want to say estimate f of 7 and f of 4. Now I say without using f of t because yes, I understand that there's an equation in this that we could just plug in 7 and 4 to. But the thing I wanted to remind us of is the process of using, some value. So we have f of 5 and we have f prime of 5. And remember, if you essentially have those two values, the original and the derivative, for a certain value, that you can use those to approximate the value of the function for nearby values. So if we want to estimate f of 7, we have to start with f of 5. But then remember, since the derivative essentially tells us if we increase by 1, how much our y values increase by, if we want to go from 7 to 5, well, that's not an increase by 1, it's increase by 2. So we have to add on 2 kind of derivative values, if you will. So we have this 5520.33 plus 2 times the 109.3. And this will give us an estimation of F7. We could, of course, triple check to see how nice it is with plugging into the original function, but I don't actually care about that here. And then if we want f of 4, well, we still need to start at f of 5. You always need to start at the value that you're actually given. But here, since we want to go backwards, we need to subtract off derivative values. And then the difference between 4 and 5 is only a difference of 1. So we only need to subtract off 1 derivative value. So we have our 5520.33 plus, minus the 109.30, which will approximately give us $5,411.03. So remember, you don't have to be given an original function to be able to get an estimate of values as long as you're given an original function and its derivative value. And remember that they have to match. Like, you can't be given f of 5 and f prime of 6. Like, that won't get you anywhere. But if it's f of 5 and f prime of 5 or any other pairing, you can do so. And also remember, the farther you go away from the original value you're given, the worse the estimation is probably going to be. Questions, concerns on any of that really long, lots of different pieces question? I think we have time to go through maybe one more. And then again, I will be posting the rest of these on Blackboard if any of you want to look at it later. All right. I want to go down to this one. So it says a rival shoe company because the one before it was about another shoe company. But anyway, a shoe company finds that their revenue function is given by 2x squared plus 15x, and their marginal cost is given by 6x minus 35. They know that their fixed costs are $75. Find the company's cost function, and then find the production level that yields the maximum profit. What is the maximum profit? So this is kind of a little bit of chapter 5 and a little bit of chapter 4. So the first thing we want is the company's cost function. So we're given and now I know x's instead of q's, but we're given the marginal cost here. So if we want the original cost function, we actually need to take the antiderivative. So if we want the antiderivative here, remember, so now we just did derivative rules, so switch back to antiderivative rules. The 6 comes along for the ride. We add 1 to the power, divide by the new power. Antiderivative of a constant is that constant times x. Now, since this function is c, I know we usually have a plus c at the back, but I'm going to make it a plus k just to differentiate between the function c and the constant. So I'm going to make it a k instead of a c. That's fine. You can make it whatever letter you want. So we'll essentially have 3x squared minus 35x plus k. And then essentially the fact that they tell us that the fixed costs are $75 is going to allow us to essentially solve for the k value. Now here, I know that technically you can probably tell where it's going to go anyway, but the full process would be, if it's a fixed cost, that means that we plug in 0. So if we plug in 0 here, that should give us 75. Well, since it's a polynomial, those first two essentially just go to 0, and we just get that the k value is 75. So the cost function that we were looking for is 3x squared minus 35x plus 75. And now we're asked to essentially maximize profit. So for review's sake, let me remind us of something. Technically, if we want to maximize or minimize a function, that's when we need to find the derivative and set it equal to 0. We need the critical points. So technically, we'd want to be finding the, nope, I'm using x in this question. We'd want to find the marginal profit and set it equal to 0. Remember that since the marginal profit is the marginal revenue minus the marginal cost, you can also find profit is 0 by setting the marginal revenue equal to the marginal cost. So we could do either way here. Since I'm technically going to need the actual profit function towards the end of the problem, I'm just going to go ahead and find the profit function and set the derivative of profit equal to 0. But just for review's sake, if you wanted to find the marginal revenue and then set it equal to the given marginal cost, you would get the same critical points. But since we're going to need it, let's go ahead and find the actual, find the original first. Let's go ahead and find the actual profit function. So we'll have revenue minus cost. So our revenue function is given to us as 2x squared plus 15x. And then our cost function we just found. And remember to always put your cost function in parentheses so you remember to distribute the negative. So we're going to distribute that negative. So we'll essentially have 2x squared minus 3x squared to give us negative x squared. 15x plus 35x to give us 50x. And then minus 75. So we're going to need to find the derivative of this and set it equal to 0. So if we find our derivative, bring the power down, so negative 2x to the first plus 50. Set that equation equal to 0 because we want to find our critical points. I would bring the 2x over to the other side. Divide both sides by 2. You get x equals 25. Now, technically, this is one of our global max or min problems. So remember, on global max and mins, we need an interval to work on. So we need to consider our interval first. Let's talk about interval. Well, we're talking about this x value, which is technically the quantity. So it's the smallest x could be. Well, that's technically 0 because, also to clarify, they didn't give us explicitly the interval. Sometimes they do, sometimes they don't. So we needed to find it here. And technically we can make as many things as we want, so this will go to infinity. Remember, when you're doing a global max or min problem, whenever it has an infinity, this is when you need a number line. Otherwise, it's when you just find the critical points and then plug everything into the original function and compare y values. But since we have an infinity here, we're going to need a number line. And remember, that number line is in terms of the derivative of the thing we're trying to maximize or minimize. So it's going to be a derivative number line for the profit function. I'm going to go ahead and remind us that we're going to stop at 0, and then I'm going to plug in 25 as my my critical point. And remember, the point of doing this is that you need to actually make sure that there is a global max, because depending on the shape of the graph, there might not actually be a maximum. It could be going up forever. So we choose some test points. So I don't know, I'm going to pick 1 and 50. And then remember, we take those test points. Anything that's on the number line is going to go into the proper derivative. So we're going to plug it into the derivative of profit. So we'll have -2 plus 50 gives us positive 48. So a positive value there. And then if we plug in, what did I choose? 50. Remember, it doesn't matter what value you choose as long as it's, you know, in the correct correct part of the number line. So we'll have -100 plus 50. So -50, so we'll have a negative there. Remember your relationship between the derivative and the original function. So if the derivative is positive, the original function is increasing. The derivative is negative, the original function is decreasing. So essentially the shape of this tells us that it's going downwards forever in both directions. So that means that a global max can exist. I know we weren't asked for minimum, but just in case we were, there wouldn't be a minimum here because it goes down forever. Therefore, there's no global min. But since the shape of this graph tells us that there is a global max, that global max is going to occur at that local max. So we'll have a global max at x equals 25. And then we were actually asked for the maximum profit, which is also a good point because with these global max or min problems, you usually want both values anyway. So we would want to know the original profit function evaluated at 25. Where's my original profit function? So my original profit function was up here. So we'd have negative, 25 squared plus 50 times 25 minus 75. That gives us something. 550. So not a lot of profit, but their maximum profit here is $550 when they sell 25, what was this, a shoe company? Pairs of shoes. So remember, whenever you want to maximize or minimize something, find the derivative, set it equal to 0. If it's a local max-min problem, then you just do the number line in general, and you just figure out if it changes from positive to negative or vice versa. With these global ones, that's where if you have an interval that's closed or open without an infinity, essentially you have an interval without an infinity. You take all of your endpoints and your critical points and plug them into the original function and compare y values. Otherwise, we have to do this little number line situation if we have an infinity floating around. Questions, concerns about that one? All right, well, we're out of time. So I will fill out the rest of this. There's another cost revenue type of problem, and then there's another one that goes over maxes and mins, and then the last one is kind of more chapter 5, chapter 6 material. But I'll put up the answers for those on Blackboard. I'll also put a blank one up in case you want to try the other ones before looking at the answers. Again, the kind of more official review is in the exam folder where the other reviews had gone. And the answers to that will be up when I get a chance by tomorrow at the latest, hopefully. If you want your exam 3 back, send me an email. I can scan it to you. I think that was it. Your homework's due on Wednesday. Your exam's on Wednesday at 12:30. Otherwise, this is the last time I'll see you unless you pop by the office hours for the rest of the week and study well. And I hope the rest of the semester goes really well. If you have any questions, feel free to stick around. Otherwise, have a great day.